The University of Texas at El Paso College of Engineering, in collaboration with Halliburton, presents Fossil Fuels. As the demand of energy grows rapidly, scientists and engineers are looking for new ways to generate energy, while ensuring a sustainable future. Due to the limitations of non-renewable resources such as fossil fuels to generate energy, renewable technologies such as solar energy, wind energy, geothermal energy, and hydraulic energy have been investigated. One of the main factors that makes humans to look for alternative solutions for the production of energy is due to the pollution that is produced by fossil fuels. Solar energy has become a very attractive alternative to overcome the demand of energy. There have been emerging technologies based on solar energy, such as photovoltaics and solar thermal collectors. Solar thermal collectors are used to capture the sun rays and take the advantage of their energy for other purposes. There are two types of solar collectors: heat collectors and collectors that produce electric energy. Let's start with heat collectors. Heat collectors use the sun rays to heat water or air. The most common use is for buildings or houses, where the demand of heated air or water is excessive. For example, laundry facilities. There are two types of heat collectors: flat plate and evacuated tube collectors. Flat plates consist of a thin sheet insulated which will absorb the sun rays. Water circulates in a pipe under the thin sheet where it will be heated by the sun rays. Evacuated tube collectors are composed of multiple evacuated glass tubes, each containing an absorber plate fused to a heat pipe. This heat will be transferred to water or air. Solar collectors for electricity generation use direct solar energy conversion, especially concentrating solar power technologies, CSP. Concentrating solar power technologies use lenses or mirrors to concentrate a huge area of sun rays into a small area where a heat transfer fluid will be heated in order to produce electricity. There are currently 4 different CSP technologies: parabolic trough, Fresnel reflectors, dish Stirling, and solar tower. Parabolic trough has reflectors which are linear parabolic. The sun rays will be reflected to the focal line of the reflectors, where a pipe will be located and a fluid will be heated. Fresnel reflectors use curved mirrors which reflect the sun rays to an absorbed tube where the heat transfer fluid will be heated. Dish Stirling is a mirror dish that concentrates the sun rays onto a receiver that is located in the focal point of the dish. Solar tower uses reflectors called heliostats which concentrate the sun rays in a solar tower. Parabolic trough is the current most common CSP technology that is used to produce electricity. CSP technologies use power cycles in order to produce electricity. The power cycle most used is the Rankine cycle. Now we will see how a CSP plant works. This cycle uses 2 fluids. One fluid will be the heat transfer fluid, most of the time is molten salt, which will be heated by the CSP system. The second fluid will be steam, which will drive the turbine to produce electricity. First, the heat transfer fluid will leave the storage tank and will go to a tower that will be heated by the reflection of the sun rays in the heliostats. Once the heat transfer fluid has been heated in the tower, it will go to a thermal storage system. The fluid can be used immediately or later. When the fluid is needed, it will leave the storage tank and will go to a heat exchanger where steam will be produced, and it will drive the turbine to produce electricity. The heat transfer fluid will exit the heat exchanger and will go back to the storage tank, and the process will be repeated. The efficiency that is produced with this cycle is only around 20 to 30%. Power cycles with higher efficiencies are being pursued to reduce the levelized cost of energy from CSP technologies. These systems, which include supercritical carbon dioxide Brayton cycle and ultra-supercritical steam cycles, require higher temperature than those currently being used. Current central receiver technologies employ either steam as working fluid and molten salt as the heat transfer medium. One of the disadvantages of the molten salt is that it cannot reach temperatures higher than 600 Celsius because it becomes chemically unstable and it causes corrosion to the pipes. The supercritical carbon dioxide Brayton cycle is currently being studied because it can reach efficiencies above 50%. Supercritical carbon dioxide can reach really high temperatures and pressures. It is well known that at higher temperatures and pressures, the thermal to electric efficiency will increase. Future work for CSP technologies is to include new power cycles such as supercritical carbon dioxide Brayton cycle in order to increase the efficiency of the system. Thermal energy storage will be added to the high-efficiency power cycles in order to supply the demand of energy when the sun is not available. For example, cloudy days or at night. Falling particle systems for solar tower is also future work for CSP. Falling particle system at high temperatures can also produce efficiency of 50% or more in comparison to the current CSP technologies. Large-scale plants will be introduced in order to produce greater efficiency. For example, larger solar tower can range from 250 Celsius to 1000 Celsius, which increases the thermal to electric efficiency. Photovoltaics are another alternative to take advantage of the energy provided by the sun to produce electricity. Photovoltaics rely on semiconductor materials that exhibit the photoelectric effect. In general, the working mechanism behind the idea of photovoltaics is to utilize the photons coming from the sun, which have a particular energy level depending on their frequency, to knock out electrons from their orbitals in the material in order to produce an electron flow or electric current. Photovoltaics are of interest for different reasons, such as buildings or transportation mechanisms. Thank you very much for watching. If you like this video, give us a thumbs up and subscribe.